So this is Nathan, Nick, Billy, I'm Matt, and this is ECE 2305, Group 11. Hi, I'm Matthew Sher from ECE 2305, Group number 11. So we built our wireless communications project around autonomous blinds to help with the energy efficiency of a home. So the real-world application of this project is to help with the energy efficiency of a home through operating autonomous blinds to help keep a house cool. So we implemented this project by creating one master aggregator and several slave temperature sensors. So the slave sensors are responsible for gathering temperature data and actuating the blinds, while the aggregator is responsible for accumulating data and pushing it to a server. So we have created a TDMA network where the time is divided by the aggregator node. Initially, the aggregator will poll for slaves to join the network. Once the slaves have joined, the master will send a packet out to the first slave. The slave will then receive the packet and formulate its own packet with the temperature data, and then push it back to the aggregator. The packet itself is 4 bytes containing destination information, sender information, the type of data being sent, and then finally the data information itself. Once the aggregator receives the temperature data, it then pushes it to a web server where it can be viewed in a text file. So the information is pushed from the Arduino itself through a serial port, which is then read by a Python script. The Python script then writes it to a text file, which is uploaded to a web host. This is the aggregator node connected by micro USB to USB on a computer. So this is the web host that we push our text file. This is the text file itself. As you can see, we have information from nodes 1 and 2, which are currently attached to the network. Sometimes they drop out, sometimes they join back in. It depends on the signal strength. And here we can see that in one place it's warm, one place it's cold, and then once we refresh the page, we get more information that we can then scroll through. Go.
Here we have one of our sensor nodes, and as you can see by this colored LED, it is currently too cold in the building. As I hold my fingers on the sensor will increase the temperature, and the LED will turn off, indicating that the motor would be running in this scenario. And then as the room cools back down again, the LED will come back on, indicating that the blinds would close.
This is our master with 2 slaves running independently of each other. The master is polling for data, and you can tell which slave is being polled and sending back data by the flashing. So this is our master aggregator. This is our slave temperature sensor. This is our slave and master communicating, transmitting the
I'm now
temperature
going
sensor.
to put my finger on the temperature sensor, and it should increase.
Slowly.
My
Yep,
fingers are pretty
there we go.
cold.
There we go. See? Increase in temperature. It works. So this is the output signal when the temperature is cold. And then when we put a finger on the temperature sensor, we gradually increase the temperature, and eventually this will trigger. So there we go. There we go. That's the trigger.